Hello guys, today we are discussing the problems on B and B plus tree. This is the first problem. This is taken from GATE 2010. Consider a B plus tree in which the maximum number of keys in a node is 5. What is the minimum number of keys in any non-root node? Assume order of B plus tree as P. So the highest number of keys is given, that is 5. That means the order will be 6, one more than key, because the pointers started before the key and it remains between 2 key, and also after the key, after the last key there is another pointer, so it will be one more than the total number of keys, 6. Now the formula for counting minimum number of key is ceiling order by 2 minus 1, that is 6 by 2, 3 minus 1, 2. So why this calculation? Because if the number of keys are less than the minimum number of key, then we need to balance that node. How it will be balanced? If the sibling node has lesser number of key, then it will be merged with that, or we will take the sibling node and this node, then we will divide them 2. Suppose in sibling node there are 5 keys already present and here 1 key, so we will merge this 5 and 1, 6, and we will divide into 2, that means 3 3. Okay, the next, consider the following 2 3 4 tree, B tree with minimum degree of 2, in which data item is a letter. The usual alphabetical ordering of letters is used in constructing the tree. What is the result of inserting G in the below? So this is a tree. The degree can be 2, 3 or 4. That means maximum 4 pointer can be there, maximum 3 keys can be there. So we have to insert G. Now G will be inserted in the first node BHI, because G is lesser than L. So what we will do, we will insert the G in the first node and it will be splitted, and one node will go up, but this LPU, it cannot contain the 4 node, but one node has to go up. So this root node will again be splitted, and one key will go upward, that will be the root of the tree, and below that root there will be 2 node which will contain 1 and 2 keys. So this is not the final answer. This node will not contain the 4 keys. The final answer will be, there will be a root node, so tree height will be increased by 1. The next, with reference to B plus tree, index of order 1 shown below, the minimum number of nodes including the root node that must be fetched in order to satisfy the following query. Get all records with search key greater than or equal to 7 and less than 15. So how many nodes we need to traverse? Suppose for 7 we will compare with 9, it will go to leftward. The left side we will compare with 5, okay, it is greater than 5, then we will go to right side. Now it will reach this 5 7 node. Now from this 5 7 node we have to traverse in right side, because 15 is there, but we cannot traverse again for 15 from root node. In that case 3 nodes will be traversed, but if we traverse in leaf nodes, then only 2 nodes will be traversed, that is 9 11 and 13 15. So total traversal will be 5 nodes, and that is the answer. The common mistake is students will start counting for 15 from the root node, and they will find again 3 nodes, though they will write answer 6, and that will be wrong. The next question is, a B tree of order 4 is built from scratch by 10 successive insertion. What is the maximum number of node splitting operations that may take place? So the catch of this question is, they have not given you the keys. You have to decide what are the 10 keys you will insert so that you can have the maximum number of split. So first we are choosing 10, 20, 30 just abruptly. Then when we are choosing a new node 40, it will be split in one node 10, 20 and another node 40. Next node we will choose such a way that it comes to the more weighted node, that is 10, 20. So we are taking something lesser than 30, 25 we have taken. 25 will come to this first node, 10, 20, 25. Now the next node we will choose in such a way that it comes to this bigger node, so that we can have the maximum number of split. So again we have taken number less than 30, previously it was 30. So we have taken that 15. Now this 15 will create a split, 20 will go up and it will be inserted in root. Again we will take another number that is lesser than 20, we are taking here 5 will come to first node. And in the next phase, when we are taking 7, not 7, we are taking 2. In next phase we are taking 2, then it will be another split, and one number will go up, that is 10. So the root is full now, because in the this is order 4. So next we are taking again another number that is lesser than 10, because we have to target the first leaf, that is the most populated. So 7 will be inserted, there will be no split for this. In next place we are taking 1, so the first node will be split when you are inserting 1. One number will go up, that is 5 we are taking. Now when you are taking go up 5, the root node will be split and 20 will be go up. In this way 2 split will be there. So total 5 split for the 10 successive insertion. 5 split is the answer. So okay guys, we have seen some gate questions. Thanks for your patience. We are ending the session here.